Now we come towards important facts of the elasticity. This we have already discussed, but now we are again repeating them. Uh, there are certain facts about elasticity. That is, for example, if we consider a steel wire and a brass wire, and we apply the same force, that is, if they are loaded with the same weight, then they are slightly stretched. But the moment we remove the load, we find that steel wire will come to its original position earlier as compared to the brass wire. That is, steel is supposed to be more elastic as compared to brass. So now we come to the main concept. Now the main concept is like this. On twisting means spinning a wire. On twisting a wire or a rod, shearing strain is produced. That is, there will be angular variation. The restoring torque. Well, now I will just highlight this particular point. The restoring torque. Whenever we apply force for twisting, then the tendency of the wire will be to come back to its original position. All atom wants to come back to the original position. So what happens? A restoring torque takes place. The restoring torque produced in the twisting through a unit angle in radian is called torsional constant. So one is interatomic constant, now other is called the torsional constant. This torsional constant means that is, whenever we apply force, we find that all atoms want to come back to their original position. So twisting through a unit angle in radians is called torsional constant. Now torque will be C multiplied by theta, and C will be pi neta r to the power 4 divided by 2L. R stands for radius of the rod and neta stands for that is coefficient of rigidity, and C is the couple, restoring couple. L is supposed to be the length of the rod, neta is the modulus of rigidity of the material. If a wire or a rod of length L is twisted at the other end through angle theta by clamping its one end, the shearing strain will be given by psi. It is produced on the surface. R theta is given by L psi, or psi will be R theta by L. This is all when the wire or the rod is twisted. The work done in twisting, again work done is there. The work done will be given in joules and it will be force into displacement, but it is an angular displacement, twist. Therefore, it is given by composition. W, that is half C theta square joule. This work done is stored in the twisted wire or a rod, and that work is called the elastic potential energy. So work done in twisting is equal to elastic potential energy of the rod or the wire. Now, in general, the springs are made from steel and not of copper, because steel is more elastic and copper is less elastic. Now we will highlight it. That is, general springs are made of steel and not of copper, because on removing the applied deforming force, the steel spring comes back to its original state more quickly as compared to brass or copper. So we will say steel spring recovers its original state more quickly in comparison to copper spring, as Young's modulus of elasticity of steel is greater than that of copper. On maximizing the impurities, suppose that we add impurity in a material to be elongated, it means those impurities will also have certain atoms. So on maximizing the impurities in a material, its elastic properties are changed. In general, the value of elastic properties increase. Body of mass m is suspended from a massless wire. Well, when we use this term massless wire, it means that we are assuming it because every wire has got some mass. No doubt we are taking that is a wire of very, very less mass. So body of mass M is suspended from the massless wire of length L. When we suspend the mass, it means weight of the mass is mg. So mg is the downward vertical force and L is the original length of the wire. And the cross-sectional area of the wire is A, which is supposed to be pi r square. If Young's modulus of elasticity is Y, then its frequency when it is made to oscillate in a vertical plane will be, that is coefficient of rigidity, that is neta, is equal to 1 over 2 pi into Ya over ml, where Y is the Young's modulus of elasticity and A is the area, M is the mass suspended, and L is the real length of the wire or the rod. If a solid is pressed, its interatomic distance decreases. So when we are pressing a solid, the position of atoms within that solid change and atoms begin to come close to each other. So separation decreases. So that is, if solid is pressed, its interatomic distance decreases. When the distances are not, that is in the equilibrium state or equilibrium distance, the potential energy becomes minimum on decreasing the distance of the potential energy increases. So on decreasing the distance, potential energy decreases because it is the product of force and that is displacement or distance. Now, in general, the iron girders are made in the shape of I, due to which the width of their upper and lower faces are comparatively larger due to their weight decreases. In this way, without decreasing the length of the girders, the material used in girders can be saved. The depression of the beam load. Depression means atoms of the loaded beam come closer to each other. The depression of the beam loaded in the middle and supported at the ends is given by function, that is sigma is equal to W into L cube over 48 Y into Ig is equal to W L cube over 4 Y BD cube, where D is the change in diameter, L is the length, Y is the Young's modulus, and W is that is elastic potential energy. Now, in this function, as I have explained you earlier, L is the length, B is the breadth, D is the thickness. We are referring to diameter. And Ig is the geometrical moment of inertia. Well, you can remember that the moment of inertia is given by function L square plus B square divided by 12 into mass of the material body. So depression of the cantilever. The cantilever means that rod whose both sides are connected with certain load. So the load will make the wire to try to go down, and in that condition the wire slightly bends, and that is called a cantilever. So depression of cantilever, a rod whose one end is fixed and other end is loaded with weight, is sigma is equal to WL cube divided by 3y into Ig. Ig is equal to pi r to the power 4 over 4 for a circular cross section, and Ig is equal to BD cube by 12, that is for a rectangular rod. In making the cycle frames, hollow pipes are used because it reduces its weight without decreasing the strength of the frame. The coefficient of elasticity decreases with the increase in temperature. If work is done in producing a strain is again the ratio of the change in shape to the original shape. So work is done in producing strain, means changing the shape in a body. The energy spent is stored in the body as elastic potential energy. For an incompressible liquid, well, before proceeding forward, uh, you can remember like that there is no liquid which is totally incompressible. Every liquid gets slightly compressed. So it is a case of assumption. That is, for an incompressible liquid, the bulk modulus of elasticity is K, and that is infinite when we press it. All materials like solids, the liquids, the gases have a finite bulk modulus of elasticity, that is K, but the Young's modulus Y and the modulus of rigidity neta are defined for the solids only. To check the volume expansion, that is gamma, of a solid, like a piece of metal, by increasing its temperature, the pressure required will be K gamma delta T. Gamma is the coefficient of cubical expansion, that is the volume expansion. Delta is the change in temperature, where K is the bulk modulus of elasticity and gamma is volume coefficient of expansion, and that will be gamma is 3 alpha and delta T is increased in temperature.